Okay, in this section 1-8, we're focused on angle pairs. And the first vocabulary word we come to is the word adjacent. Now, let's read through the definition and then we'll talk about each part of it. Okay, adjacent angles are coplanar, and they have a common vertex and a common ray, but no common interior points. Okay, so for two angles to be adjacent, number one, they've got to be coplanar. Remember, that means on the same plane. So you've got to have two angles that are in the same plane. They have to have a common vertex. That means they've got to have the same vertex. So if point A is the vertex for one of the angles, then point A has to be the vertex for the other one. Okay, they have to have a common ray. That means they've got to have a common side. But no common interior points. That means they cannot overlap. All right? So let's take a look at two angles and kind of see if they're adjacent or not. So let's say I looked at angle AB or ADB, which is here, and BDC, which is here. I'm looking at these two angles and I'm trying to decide whether or not they are adjacent. All right, so number one, are they coplanar? Yes, they're in the plane of the paper. Do they have a common vertex? Okay, the answer is yes. Both of these have a vertex of D. D is the common vertex. I can tell by looking at the figure that D is the point to which both of the angles originate from, or by looking at the notation, D is the middle letter in each one of those. They do have a common vertex. Do they have a common ray? In other words, do the angles share a common side? And the answer is yes. Ray DB, okay, is a common ray for the top angle, and it's also a side of the bottom angle. So they share that side. That means they're connected at that side. Okay, and they do not have any common interior points. Where this angle stops, that's where the other one begins. All right, so these two angles, ADB and BDC, fit the definition of adjacent. So I will say that these two angles are adjacent. Okay, these two angles are adjacent. Okay, now let's look at another set of angles. Angle ADB and angle ADC. So ADC is this full angle from here to here. So these are now the two that we are looking at. All right, so we want to decide whether these two are adjacent, yes or no. Are they coplanar? Yes. All right, they are in the same plane, the plane of the paper. Do they have a common vertex? Yes. Point D is the vertex of both. A common ray? Yes. Ray DA, this top ray, is a side of the smaller angle and a side of the bigger angle. Okay? Now, here's where it fails on this last point. Okay? They do have common interior points, because if I put a point here, then this point is in the interior of ADB, and it's also in the interior of ADC. So all of this area would be considered common interior points. In other words, they can't overlap. They can't share. All right, so these are not adjacent. These are not adjacent because they overlap each other. This angle and this angle, they have overlapping points. Okay, so the easiest way to think about adjacent is they've got to be right next to each other with no gap and no overlap. No gap, no overlap. So in other words, if this is one angle, the other angle needs to start right here at this side and then continue this way. Okay, so that's the easiest way to think about adjacent. They're together with no gap and no overlap. Okay, here are two other examples of angles that are not adjacent. This angle and this angle are not adjacent. Why? Because there's a gap here. They don't share a common side. These two are not adjacent because they don't share a common vertex. All right? So again, adjacent angles, they should be connected at one side with no gap, no overlap. All right? The next definition that we come to are vertical angles. Vertical angles are two angles formed on opposite sides of intersecting lines. So like, for example, right here we have two intersecting lines. I've got this angle labeled as angle 1. I've got this angle labeled as angle 2. Okay, they are formed, okay, on opposite sides of intersecting lines. So if this is one angle, if you've got two lines that intersect, its vertical angle would be on the opposite side of it. So if you just trace it through, you would go to the vertical angle. So I can now say 1 and 2 are vertical angles. Okay, they are vertical angles. Okay? Now, here's something else that we need to make a note of. Write this statement down. Vertical angles are congruent. Vertical angles are congruent. That means they have the same angle measure. So if angle 1 is 50 degrees, angle 2 also has to be 50 degrees. They are the same measure. If you've got several lines that are intersecting, then if you wanted to find, say, the vertical angle to this angle, trace it straight back, and the one exactly on the opposite side is the vertical angle to it. All right? So in this case, the two that are outlined are the two that are vertical. Okay? So vertical angles. They're on opposite sides of intersecting lines. Okay, next word that we come to is linear pair. Linear pair is two adjacent angles that are supplementary. So if they're adjacent and supplementary, adjacent meaning connected together with no gap, no overlap, share a common side, and supplementary, they add up to 180, they have to be a linear pair. So for example, okay, angle ADB from here to here, angle ADB, and angle BDC from here to here, BDC, form a linear pair. They form a linear pair. And again, are they adjacent? Yes, they're connected by this ray, right? These two angles are connected by this ray. They have a common vertex. They're in the same plane. They have no common interior points. So they are adjacent. Are they supplementary? Yes, because these two here add up to 180. Now, how do I know that they add up to 180? Here's the key. I know that they add up to 180 because these two angles together make half a circle. And half a circle is 180 degrees. Half a circle is 180 degrees, right? So anytime they're together, if they make 180 degrees from one side to another as a straight line, then you know that they are supplementary. And if they're supplementary and adjacent, then they would be considered a linear pair. All right? So now that takes us to the angle addition postulate, and here's what it states. If D is in the interior of angle ABC, then the measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. All right, now let's trace this out and see exactly what it means. So, if point D is in the interior of ABC, so we have point D right here, it is in the interior of angle ABC, it's inside of it. Okay? Then the measure of ABD, so ABD, so this angle here, plus the measure of angle DBC, which is here, okay? Those two should add up to the bigger angle, ABC, which is this full angle from here to here, all right? So in other words, this angle plus this angle should add up to the whole thing, and it does. Okay, so if the top angle here, angle ABD, was 25 degrees, and the bottom angle, DBC, was 45 degrees. If I add those two together, I would get the bigger angle ABC, which would be, in this case, 70 degrees. All right? So the angle addition postulate is just like the segment addition postulate, except it's for angles. Okay, so angle addition postulate says a segment is the sum of its pieces, and this one says that this big angle is the sum of its pieces. All right, so angle addition postulate, very similar to segment addition postulate in what it says. Okay, so now we've got a diagram, and we have several questions that are asked about the diagram. All right, and the first question that we come to, it says, name an angle adjacent to angle FGE. Name an angle adjacent to angle FGE. Well, the first thing we have to do is locate the angle, trace it out, FGE. FGE, all right, so that's on the bottom of the figure. There's my angle. All right, so I need to name an angle that's adjacent to it. Now remember, The easy way to think about adjacent is they're connected with no gap and no overlap. Okay? So if an angle is going to be adjacent to angle FGE, it's got to be connected to one of these sides. Okay? So let's just see if we can find an angle that's adjacent on this side, the side with ray GF. Okay? So if I start off with this as one of my sides, I've already got 2 out of the 3 letters in the angle that's adjacent to it. So it's got to be angle FG something. It's got to be angle FG something. And all you've got to do, because remember, it's got to be connected to one side of the angle. All you've got to do is finish the angle in a direction that doesn't cause overlap. So we can call it angle FGA would be one angle that is adjacent to angle FGE. All right, that's one of them. There's also another one that's drawn there on the same side. We could say angle FG, and we can extend it all the way out to B. FGB would be an angle that's adjacent to the angle that's given. And likewise, there's 2 on the other side. Okay, so EG is the ray on this side of the angle, so EG would be my first 2 letters in an angle that's adjacent to it on that particular side, and all we got to do is finish it. EGD would be one, and then also we can extend it out to EGC. EGC would be another one. All right, so all 4 of these are angles that are drawn on the figure that are adjacent, and all you would have to do is answer 1. All right, so remember, adjacent, it's connected to one side, either this side of the angle or this side of the angle, and then you finish it off, and that gives you 2 of the 3 letters. And for the 3rd letter, you just finish it off in a direction that doesn't cause it to overlap back over the angle. Okay, so if you got one that's adjacent to this side, you need to continue going this way away from the angle. You can't go back over it. So FGD is not adjacent because of the overlap. And on this side, if you're connecting to this side of the angle, EG, then make sure you're going in the direction that's away from the angle that you're trying to find one that's adjacent to. Okay, so let's move to the next question. It says name an angle vertical to EGD. All right, so let's locate angle EGD. EGD is here, so this is the one that we're looking at now. And remember, your definition of vertical angles are 2 angles that are formed on opposite sides of intersecting lines. So if I wanted the angle that was vertical to EGD, then I would trace this angle straight back, and this would be the angle that's on the opposite side. So I would call that angle AGB. So AGB is the angle that's vertical to angle EGD. All right? The next one. Name an angle that forms a linear pair with AGB. All right, so AGB is here. We'll locate that first. And we're looking for an angle that forms a linear pair. Remember, linear pair together adds up to 180. So if I start here, then the other angle that I need an angle that forms a half a circle, 180 degrees. So this is part of my half circle. How do I finish it? Well, first of all, it's got to be adjacent to this angle, which means it's either got to be connected to this side or this side. So let's start with the one that's connected to this side. So how far do I need to go out? And I can go ahead and start with the first few letters. This is BG something. BG something. So I need to finish it with the letter of the right ray that would make this 180 degrees. So I've already got this part. Well, to finish it, I need to go out to here to make a full half of a circle. So an angle that forms a linear pair with AGB would be BG and then D. So remember, anytime they ask you this question, name an angle that forms a linear pair, you've already got 2 of the letters of the answer. Okay, you've already got 2 of the letters of the answer, all right? Okay? And so if it's AGB, then one that's vertical to this side would be BG something, and then finish it out to make half a circle. Now, there's also one on the other side that's connected to it. In other words, to the side that's connected to ray GA. All right, so I know if I want one that's a linear pair with AGB on this side, it's got to be AG something, because it's got to be one connected to this other side now. And now I just need to take this out to make a half a circle. Well, let's draw a half a circle. Here's part of it. If I take it out to here, that wouldn't be a full half a circle, so it can't be AGF. But I can take it out to here, and now I've got half a circle. So it'll be AGE as my correct answer. Okay, now, some students have real difficulty trying to identify an angle that forms a linear pair with another angle. Remember, when you're done, when you trace out those two, you better have a half a circle. If you don't have a half a circle, you don't have the right answer. So again, if you're saying that these two are a linear pair, AGB, trace that one, and then AGE, trace that one, those two together better make a half a circle. All right, in other words, from one end to the other, you got a straight line. Okay, if it's not half a circle, then it cannot form a linear pair. Keep that in mind. All right, the remaining questions have to do with angle measure. And so let's take a look at those. If BGA is 60 degrees, BGA is 60 degrees, the question is, what's the measure of DGE? Well, DGE is here. And what do you notice about these two angles? Well, you should notice that they are vertical. And remember what we wrote down on the other page, vertical angles are congruent. They have the same measure. So if this angle is 60 degrees, okay, then the vertical angle to it should also be 60 degrees. All right, so 60 is your correct answer there. Okay, the measure of AGB is 70. Let's find it. AGB is 70. All right, so that's actually the same angle as what we just looked at, but this time we're saying it's 70 degrees. Now, what are we asked to find? We're asked to find the measure of angle BGD. BGD is from here to here. All right, so one thing that you should notice about these two is they form a linear pair. Together they make half a circle. So if they form a linear pair, they should add up to 180. So 70 plus what adds up to 180? The answer to that is 110. 110 plus 70 will add up to 180. All right, so we know from here over to here is 110 degrees. All right. Now, the next one we're looking at, AGC is 140. AGC from here to here is 140. That's from here over to here. And we want to find the measure of BGC. BGC is here, only this part of it. All right, so here's what we've got. We've got this angle from here to here is 140. All right, and I want to actually not find. This also should be given to me. And so let's give this as 80 degrees. So this part right here is 80 degrees, let's say. And if this is 80, then the question is to find the measure of angle AGB. AGB. Well, remember, these two together should add up to 140 by the angle addition postulate. These two should add up to 140 by the angle addition postulate. And so what plus 80 adds up to 140? 60 plus 80 will add up to 140. If you subtract those two, then you will find that that's 60 degrees. All right, so there you go. Keep everything that we learned in mind now while you're doing your quiz for this section.